Hello everyone, and welcome to another remote sensing lecture video. And in this lecture video, I want to wrap up our discussion talking about the different types of values that can be measured by a sensor. And I want to do that by going through a numeric example. So keep in mind that these numbers have been made up by me, but it's just a good way to sort of walk through the different pieces, the different components, see where the components go, and see why the different values are the way that they are. So what I would highly encourage you to do is right now pause the video. I've already drawn all the diagrams because I wanted to spend more time talking about the concepts rather than drawing the diagrams. So I encourage you to pause the video, take time, draw the diagrams out yourself in your notes, paying special attention to the numbers here because these are going to be the focus of today's discussion. And then you'll see that we have two cases where the numbers have been changed slightly. And then we're going to go through and we're going to figure out what would be the values for top of atmosphere radiance, top of atmosphere reflectance, surface radiance, and surface reflectance. So that way you get a really strong idea of where the different components go and figuring out how these different things are calculated. So again, I would encourage you to pause the video, take time, record these in your notes. Okay, so hopefully you've done that. Hopefully you have everything transcribed into your notes. But what I want to do before we start nitpicking the numbers is I want to actually go over here and I want to fill out this includes column here that I intentionally left blank. And what this is going to be is this is going to be our chance to recap what we talked about before in terms of what different components go into the different types of measurements. So we're going to start with atmospheric radiance or top of atmosphere radiance. And we're going to think back to what that includes. So what top of atmosphere radiance includes is it includes the atmosphere. Right, it includes atmospheric radiance. Now it's important here that this includes both the reflection and also scattering. If you look back at the diagrams, we don't explicitly address scattering because it makes the diagram more complicated. But in this case, atmospheric radiance includes those two things, and then it also includes the surface radiance. So what does top of atmosphere reflection include? Well, that's going to require us to go back and think about what top of atmosphere reflectance is. So top of atmosphere reflectance, if you remember the idea of percent reflection, right, that's that radiance over irradiance. So if we're talking about the top of atmosphere reflectance, what we're talking about is atmospheric, so it's going to include atmospheric radiance, it's also going to include the surface radiance. Right, and this again is the same thing as up here. So we're talking about top of atmosphere radiance, but then we also include something else, and it's what actually defines this idea of percent reflectance, is we're going to divide that by the total irradiance. Right, by the total irradiance. And this total irradiance, right, this is the total incoming radiation. So that's top of atmosphere reflectance, right? It's the top of atmosphere radiance, which is the atmosphere and the surface, and then the total irradiance. Okay, so hopefully that makes sense. Surface radiance, well, what does surface radiance include? Well, if you remember back to our discussion about surface radiance, with surface radiance, what we've done is we've done that atmospheric correction. And that atmospheric correction took care of that atmospheric radiance. So what I want to do is I want to sort of reiterate this. So we're going to put atmospheric radiance here. And then I want to just highlight something. I'm going to use purple Actually, I'll use red to highlight that what we mean is that we do not have atmospheric radiance. And the reason we don't have atmospheric radiance is removed by atmospheric correction. Right, this was removed by atmospheric correction, and we talked about atmospheric correction in the previous video when we talked about the fact that it accounts for all the different parts of the atmosphere, and it removes that contribution from the atmosphere. So if we take away atmospheric radiance, what we have left is just the surface radiance. Right, all we have left is surface radiance. Now it seems kind of counterintuitive, or I guess maybe confusing might be the better term here, that we have surface radiance as the name and surface radiance as the thing that's included, but hopefully that actually makes a little bit of sense here, that because we've removed atmospheric radiance, what we have left is surface radiance. So let's talk then about this idea of surface reflectance. So what would be included in surface reflectance? Well, obviously we're going to be, or hopefully this is obvious, that we're going to be starting off with surface radiance. Right, surface radiance is our starting point. Right, and because we're talking about reflectance or reflection, right, just like up here, we're talking about reflectance or reflection, right? Percent reflection is radiance over irradiance. Well, in this case, we're not talking about the total irradiance because we're talking about just the surface. So we're going to talk about surface irradiance. All right, surface irradiance. So hopefully now we understand where the different components, what different components we're going to be using. So now hopefully we'll be able to see that and see our cases, okay, more or less. So we can see our cases and we can see what we include here. So let's go ahead and let's walk through the different components. So let's start with top of atmosphere radiance, talk about case 1. So for top of atmosphere radiance, what we want to include is we want to include the atmospheric radiance and the surface radiance. So let's start off by looking at our case study and say, well, what are we actually looking at here? So if we look here, we start off with a value of 100 hitting the atmosphere. All right, some portion of that is reflected off, this blue 50 here. So this blue 50 here is atmospheric reflection. All right, so we want to include the atmospheric radiance, which is that blue 50. All right, some portion of that is transmitted through the atmosphere. That's this green 50 here. And then some portion of that is reflected off, and that's this yellow 10 here. Right, so the surface radiance here is this yellow 10. So we're going to put the yellow 10 here. Okay. Right, and then if we do the quick math here, because this is the two things that are included, is the blue 50 and the yellow 10, we get a value of 60. All right. So our top of atmosphere radiance in case 1 is 60. And then we're just going to really quickly do the same thing for the case 2. In this case, we have 100. And we have 20. And then we're going to get a value of 120. So I think it's important to note here the difference between case 1 and case 2 is just that in case 2, the total irradiance is much higher. So everything else is kept the same proportion. And that'll make a lot more sense when we talk about especially about surface reflectance and why it's so important and why percent reflectance in general is so important. So all we've done is we've increased the irradiance in case 2, and you can see the top of atmosphere reflectance, or sorry, top of atmosphere radiance is already much higher. So we've changed the values fundamentally. Even though the system is the same, we just have more energy coming into the system. So that's top of atmosphere radiance. Again, we're bringing in the atmospheric reflectance or atmospheric radiance and the surface reflectance or surface radiance here. Case 1, case 2. So now let's talk about top of atmosphere reflectance. So top of atmosphere reflectance we said was atmospheric radiance and surface radiance divided by the total irradiance. So in this case, the top number is going to be the same. So it's going to be, for case 1, it's going to be 50 plus 10. And then the bottom number, the case 2, is going to be 100 plus 20. And then because this is percent reflectance, we need to divide by something. Right? If we look over here, we said we're going to talk about total irradiance. So total irradiance is going to be the top thing up here. It's going to be, in this case, it's going to be 100. This is the total amount of incoming radiation, right? Because irradiance is incoming radiation. So that's going to be 100, and that's going to be 200. So then if we do the quick math here, right, this is going to be 60 over 100, which is going to be equal to 60%. And this is going to be equal to 120 over 200, which is also going to be equal to 60%. So we can already start to tell the fact that percent reflectance, even though we have more irradiance, right, we have more energy entering the system in case 2, we have the same percent reflectance. And that's kind of an important thing to think about, because if you think about the fact that, you know, presumably whatever's on the ground here hasn't changed between these two systems, why would we want to have a different pixel value based just because we've increased the amount of incoming energy? So that's, hopefully we're starting to see why this percent reflectance is so important. Right? So now let's look at surface radiance. So for surface radiance, this is actually going to be pretty easy, right? We've already deduced that all we care about is the surface radiance. And so if we think about what surface radiance is, right, it's the amount of energy that's leaving the surface. And so surface radiance in this case is just this yellow 10. So for surface radiance, for case 1, it's just this yellow 10. And then for case 2, it's just the 20, right? And just to be consistent here, putting our answers circled in white, because we don't have to do any additional math here, it's the yellow 10 and 20. So again, hopefully this makes sense here, that because we have more energy entering the system, everything else being equal, we have more energy leaving the system in case 2, even though it's the same object in both cases. So finally, let's wrap this up with surface reflectance, I should say. And again, surface reflectance in this case is surface radiance, which we already know to be 10 in case 1 and 20 in case 2. And because it's a percent reflectance, we're dividing that by something. Now in this case, right, we're talking about surface irradiance. So surface irradiance in this case is not the total radiance, because some portion of that has been reflected off, has been absorbed, or whatever, or some other thing that's happened here. So we're talking about just the amount of energy that actually is incident upon the surface, right? Irradiance is incoming radiation to the surface. So in this case, we're talking about this green 100. And in case 1, we're talking about this green 50. So we're going to put that down underneath here, the green 50 and the green 100. So we're going to do the math here, just like before. 10 over 50 is 20%. Sorry, let me make that a little cleaner because that's got a little messy. 10 over 50 is 20%. And 20 over 100 is also 20%. So hopefully by following these numbers, you can see where different components are coming from, what different components are represented, and you can see the difference between the different types of values. So if at any point this didn't make sense, I strongly encourage you to pause the video, rewatch it, because this really does encapsulate everything that I would hope that you would understand from the lectures so far. Again, if you have any questions, please reach out. Thank you.